Today we are going to discuss symmetric matrices. Starting with the symmetric matrix. What is a symmetric matrix? As you would be thinking in your mind that a symmetric matrix would probably be a matrix which would be symmetric in figure. Then it is somewhat similar kind of that. But a square matrix is said to be symmetric matrix if it is equal to its transpose. Means a given matrix should be equal to its transpose. Then it is said to be a symmetric matrix. It means that A dash is equals to A. As I have told you in my previous video that A dash is the denotation of a transpose of matrix. So A dash should be equal to A. Means Aij of a matrix should be equal to Aji of that second matrix. So that is for all I and j, then it would be called as a symmetric matrix. As we go by the example to get the clear picture of a symmetric matrix, how we can call a matrix should be a symmetric matrix. Then here we see A is a matrix of 3 by 3, as the first thing says that it should be a square matrix. Then this is a square matrix. Then how A dash is the transpose of matrix. Then here rows of the first matrix has become the columns here. Rows, columns for second row, second column, third row and third column. So this one is the transpose of matrix. This one is the transpose of matrix. So here A dash and A both are similar. We can say by corresponding elements are equal. By comparing the corresponding elements, we can say both the matrices are equal. Like -3 is equals to -1 is equals to -1. √3 is equals to √3. 2 is equals to 2. 3 is equals to 3. 2 is equals to 2. And similarly it applies for remaining elements also. So here A is equals to its A dash, that is Aij is equals to Aji for all I and j. Then we can call it as symmetric matrix. Next in the line what we have, if we want to make any square matrix as symmetric, there is also one choice that if we want to make any given square matrix in symmetric matrix, then we need to follow these steps accordingly. It is just an example. We can follow the steps for any square matrix to make that matrix as an symmetric matrix. So starting with the first thing, we have here a square matrix of order 3 by 3, that is 1 2 3 4 5 6 7 8 9 as its elements. And here we have A dash, that is A transpose of this matrix. Here we have 1 4 7 2 5 8 3 6 9. How we can say its transpose? By seeing that the rows of first matrix is the columns of second matrix, that is 1 2 3 is the row here, first row, and then here it's the first column, that is 1 2 3. 4 5 6 is the second column, 4 5 6 is the second column here, for second row, second column, third row, third column. So this A dash becomes the transpose of A. For making matrix A as symmetric ones, this matrix we can make it symmetric. How? By adding this both. By adding A and A dash, we can make the obtained matrix as a symmetric one. So we can say the obtained matrix is a symmetric matrix. That is A plus A dash, 1 plus 1, 1, 2 plus 2. We can say 2 plus 4, 4, 3 plus 7, that is 3 plus 7, 10, 4 plus 2, 6, 7 plus 3, 10, 8 plus 6, 14, 5 plus 5, 10, 6 plus 8, 14, 9 plus 9, 18. So assume that A plus A dash is equals to B. Then we have B is equals to this. Then how we can say it is symmetric? We can say this matrix as symmetric because by equating it to its transpose. How we can get its transpose? My dear friends, I have said you in previous video, the transpose means rows are the columns and columns become the rows. So again transposing this B matrix, we get this matrix as its transpose. And mind you, this both are same. So here it says if A dash is equals to A or any matrix is equals to its transpose, then we can call that matrix as a symmetric matrix. So here we can say B is equals to its B dash, so it's a symmetric matrix. Next in the line we have skew symmetric matrix. Skew symmetric matrix means a square matrix is said to be a skew symmetric matrix if its transpose is equals to negative of that matrix. Suppose that we are given a square matrix, okay? We are given a square matrix, then its transpose is equals to negative of that matrix, then that matrix can also be called as skew symmetric matrix. Here we have an example saying that matrix B is equals to 0 1 2 minus 1 0 3 minus 2 minus 3 0, then its transpose means rows become the columns becomes the rows. Okay, so 0 1 2 first row becomes the 0 1 2 first column. Similarly for second and third also. And negative of matrix, we must be thinking what's the negative of matrix. Then here we have negative of a matrix means when a given matrix is multiplied by -1 as a scalar, then the obtained matrix is called negative of that matrix. Nothing, my friends, just very simple. It's very simple, we can say. By multiplying each element of that matrix by -1, we can get the obtained matrix is called as the negative of matrix. So we get here, this is a skew symmetric matrix. How we can say it's a skew symmetric matrix? Because the second rule also says that all the diagonal elements of skew symmetric matrix are 0. Means the diagonal elements of the matrix 0, then we can say that matrix is skew symmetric matrix. As we can see here, the diagonal elements are 0, so we can say that it is a skew symmetric matrix. And also B transpose is equals to minus B, that is negative of B. So if these two conditions are satisfied, then we can say it's a skew symmetric matrix. And mind you, if we want to make a given square matrix into a symmetric matrix once, then we need to subtract that transpose of that square matrix from the given square matrix. Means if we are given the matrix A, then we need to subtract its transpose from that. So whatever we get as the difference is nothing but a skew symmetric matrix. As an example, we can see this is a matrix A of 3 by 3, as it is said here. It's a square matrix. It should be a square matrix. Then what we do here, A transpose, we also need A transpose also, as we have to subtract it. So here we have A transpose. By exchanging the rows and columns, we can make its transpose also. Then we need to A minus A dash, means we need to subtract this from this. Let's assume A minus A dash is equals to C. Then we can say C is equals to what? C is equals to 1 minus 1, 1 minus 1, 2 minus 4, 2 minus 4, 3 minus 7, 3 minus 7, 4 minus 2, 4 minus 2, and similarly all these remaining also. Then what we get as the resultant is nothing but a skew symmetric matrix. And one more recognition of it, that is nothing but the diagonal elements. Diagonal elements are 0, as the rule said here that all the diagonal elements of a symmetric matrix are 0. Skew symmetric matrix has all its diagonal elements at 0 only. So here also we can see all the diagonal elements are 0, so we can say this as a skew symmetric matrix. And also that by obtaining it from the given rule, as the rule said here, that we need to subtract the transpose of that square matrix from the given square matrix. By obtaining the difference, we can get the obtained matrix. We can say that it is a skew symmetric matrix. Next we have very important theorem. This is very small, but mind you, it is a very sure question in our board exams. It's surely for 6 marks or 4 marks, probably it comes many times. So what theorem says here? Theorem says that any square matrix can be obtained as the sum of symmetric and skew symmetric matrix. It means that any given square matrix can be obtained as the sum of symmetric and skew symmetric matrix. How we can obtain it is by given that formula. This formula says that A is equals to half of A plus A dash plus half of A minus A dash. Then we can get the sum of symmetric and skew symmetric matrix. With this, I take leave of you. Thank you. Hoping that you must have gained some knowledge. Any doubts, any queries, just shoot it in the comment box given below and it will be solved as soon as possible. So from my side, Jai Hind.